10.3 is on composite functions or function composition. Both mean the same thing. Basically what it's doing is you're taking two or sometimes three functions and you're composing them together. So you're writing them so that they're all one function. So this says example 2, but really it's example 1. It's given the function fx is equal to square root of x minus 1 and gx is equal to x squared. Determine g that dot f, and that dot means composed, g composed with f of x. The way this is written then is you're writing g of f of x. So before when we were doing it we did f times g of x or f plus g of x or fx plus gx depending on which way you wrote it. So this is called g of f of x. So what you're doing is you're composing the f function into the g function to get a new function out of it. So if f of x is equal to square root of x minus 1 and gx is equal to negative x squared, then we need to do this composition. So what you're basically doing is you're going to do a substitution. So the g of f of x. So what you're doing is you're going g of the f of x in this case is square root of x minus 1. So what that means is wherever there is an x value in your g function, you're going to substitute in, I should have a second bracket there, square root of x minus 1. So that means that I'm going to do negative, substitute in my fx function into the x function. So it's going to be negative square root x minus 1 all squared. So if I think of this way, if my gx function is the purple, this is the gx function. My fx is being composed into that, so that means wherever there was an x, I'm going to substitute in square root x minus 1. So in this case, because this particular question only had one x, then that's the only place I'm substituting that in. So if I use my rules here then, negative square root of x minus 1 all squared, well your squared and square roots just cancel, so that's just going to be square root of x, or sorry, that's just going to be x minus 1, which equals negative x plus 1. So that is your solution. This asks you to do the domain of this function. So remember, domain is what's going to give you your restrictions. So that's why for all of these, when we've done these functions in this chapter, we've only really looked at the domain. A few questions asked you for the range, but we focus more on the domain. So what that means is I need to look at my f of x and figure out the domain for that, and then I have to figure out the domain for the g of x. So because this is a radical, what I need to do is I need to take what's under the radical sign, put it not equal to 0, or what you could do not equal to, actually probably be better because we're turning this into domain, we want that greater than equal to. So x minus 1 has to be greater than or equal to 0, because if we put a negative value in there, we're going to have a negative under a square root. So that means that x has to be greater than or equal to 1. So that is my domain for the fx. For the gx, my domain, I can put any value that I want in there. So it's x is an element of real numbers. Now if I did this with my sign analysis, for this one here, at 1 I would be at 0, and then everything to the left of 1 would be positive, everything to the right of 1 would be negative. For the g of x, everything will have a negative value, right? No matter what I substitute in there, but I can substitute in any values. So what that means is, and I won't fill in anything in here, where is it positive, or where does it work for both of these? It has to be to the right of 1. So for the composite function, g, and it's more of an open dot, it's not a dot, because if you just did a dot, that would be a multiply. So the composite function g of f of x is the domain, then is x is greater than or equal to 1, and x is an element of real numbers. Okay, so next example says, let fx is equal to x plus 1, and gx is equal to, excuse me, I gotta sneeze, is equal to x squared. Now they want us to determine the equations of each of these composite functions, graph it, and sketch the domain. So first let's do, what would the new equations look like? So for a, y is equal to the f of gx, so that's saying wherever there is an x in my f function, I'm going to substitute in the gx function. So in this case, my x squared is going to go in place of the x. So the f of g of x is going to equal x squared plus 1. Actually, I'm going to put in just an extra little step here. So what I'm substituting in here is I'm going f of, because gx is equal to x squared, so that's where that x squared comes in. So this is going to be x squared plus 1, so that's just equal to x squared plus 1. B, the g of f of x. So that means that wherever there's an x in the g function, I'm going to substitute in x plus 1, because that's what f of x is. So gx is equal to x squared, so that means I'm going to substitute in x plus 1 squared. Remember, when you square a binomial, you get a trinomial, so this is x squared plus 2x plus 1. C. Let's move this up. The f of x. So that means wherever there is an x in the f function, I'm going to substitute in x plus 1. So that means for this x plus 1, I'm going to, if that x in that x plus 1, I'm going to substitute in an x plus 1 plus 1. So this is equal to x plus 2. The last one is g of x. So that means that wherever there is an x in my g, I'm going to substitute in an x squared. So this is going to be x squared all squared. Is it a negative? No, just a positive. So this equals x to the 4. So the biggest thing to remember when you're doing this is you're substituting in a function into a variable. When you're composing a function, or when you're doing function composition, you're substituting in a equation into a variable spot. So if we were to draw these, a is equal to x squared plus 1. So I'll do that in, oops, so I see my alignment is a little off here. I'll do that one in blue. So x squared plus 1 means my vertex using my PQ values or HK values, whichever, is at 0 and 1. So I'm going to go up 1 here, And my graph will look like that. So that is fx. Gx is x plus 1 all squared. So using my PQ values or my HK values, same thing, the vertex is going to be at -1 and 0. And it's just a regular parabola. So -1 and 0 will put me at about here. And I'm not saying this actually crosses the graph at that spot, but so this was, I'll put B, because that's not actually, this is A actually, it's not f of x. Graph C then is x plus 2. So that is just a straight line with my y-intercept at 2. So if this was 1, 2 is about right here. And then my slope is 1, so it's just going to be over 1, up 1, so it's going to look something like that. So this is C. And then D is x to the power of 4. So if you were to draw that, when you're substituting in your values, 1 would be 1, 2 is going to be at 8. So that means it's going to get 0, 0, and then we would have 1 and -1. Oops, that should be up there. And then 2 would be up at 8. So that's going to be way up here, right? So what's going to happen is this graph is going to be fairly skinny, because then we go -2. Well, that's only -1, so -2 and 8. And remember, I'm sketching, so my graph is not going to be perfect. So this was D. So the question asks to state the domain and the range of each of these functions. So for A, my domain is all real numbers. That was my blue graph. My range for this one, y had to be greater than or equal to 1. For my B graph, which was the purple one, x plus 1 all squared, I can use any value for my domain. So domain is x is an element of real numbers. And my range for that one, this graph didn't go below 0 on the y, so y is greater than or equal to 0. My C graph was the red graph. It's the straight line. So I can use any number for my x value. So my range is x is an element of real numbers, and so is my range. There's no maximums or minimums. I could go on forever in both vertical and horizontal. And the last one was D. Well, D was a form of a parabola, because remember this x squared. Oh no, I'm going to leave that. I won't. That'll be too confusing. So it's x squared squared. So it's just a parabola that's been squared. So it's just changing the shape of it, the width of it a little bit. So your domain for this one, oops, that should have been green, is x is an element of real numbers. I can use any value in there I want. Your range, though, has that minimum value, so y is greater than or equal to 0. Example number 4 says if hx is equal to f of g of x, determine fx and gx. So by function composition, if we look here, this gx is going to substitute into whatever our fx equation was. So if we take a look at this one, this square root of, or sorry, cube root of x cubed. Well, oh, there's my highlighter. Cube root of x cubed here is also substituted in there. So then that means that those two must have been what was in place of my x values in my function, in my fx function. Oops. Someone doesn't want to change back for me. There we go. So that means that this had to be my gx, this cube root of x had to be the gx because it's being it's in there twice, so we can assume then that it's been substituted in for an x value. So that means we're going to say our gx is equal to cube root of x. So then that means our fx would have had to be, if gx is being substituted in to the function as the x value, so I know it's going to be x plus 3 over 3 plus, well, there's that substituted in value again, so it needed to be in there for an x. Example 5. So the spherical weather balloon is being blown up. The balloon's radius r in feet after t minutes elapsed time is given by r is equal to square root of t. So it says express the surface area of the balloon as a function of time t. So surface area of a sphere is equal to 4 pi r squared. So we want to know, we want to express the surface area of this in the function of time. So surface area is based on how long it's taking to blow up this balloon, or in this particular question, along with the radius. So if I substitute 4 pi, and because they want it to be expressed as a function of time, that means we need to have that t value in there. So we're going to substitute in square root of t for our r. So that's just going to equal 4 pi t, because my squared and square root will cancel. So B part says, after how many minutes will the surface area be 180 feet squared? So this equation here is already expressed as a function of time, so that means I can just substitute. They've told me the surface area, so that's going to be 180. My formula is 4 pi over t. I'm trying to find my time, so I know that that's what I'm going to move. So if I divide this side by 4 pi, and this side by 4 pi, I will get my answer, and it works out to be approximately 14.3 minutes is your time. So about 15 minutes. Yep. We're having technical issues here. There we go. Okay, so just a few more examples on doing function composition. So remember, when they're asking a question, find the g of f of x, it can be written in this way for function composition, or it can be written this way with that dot in there. So f composed into g, or g composition of x, of f of x. So 3x is equal to gx, and, fx is equal to 3x, and gx is equal to x squared plus 1. So if we want to find the f of the g of 2, then first thing we need to do is we need to substitute so we can put in our function composition. So the first thing we want to do, we want to substitute in, so this can be written as, better make sure I'm f of g of x. So first let's do it that way. So what that's saying is in my fx function, wherever there is a gx, in my fx function, wherever there is an x, I'm going to substitute in x squared plus 2. So there's two ways of solving this. I'm going to do it this way, and then I'm going to do it another way. But you know what? I'm going to do this one first because that's going to give us the answer. So f of g of x. So wherever there is an x squared or an x, I'm going to substitute in x squared plus 2. So my fx function was 3x. So then that means that's going to be the function of x squared plus x. So that's what my gx equaled, and I'm going to substitute that in there. So this is going to be 3 times x squared plus x, because there's only one x in that f function. So that means it's going to stay as 3x squared plus x. So if I solve it further, it's 3x squared plus 3x. Excuse me. So if I want to do this with the g, or the function composition of g of 2. So this is what I'm doing. I'm doing the function of g of x. So what I'm doing is I'm going to substitute in, and there's two ways of doing this. I'm going to do it this way first. My g of 2, because that's what I'm substituting in, is going to be substituting a 2 wherever there's an x squared in the g function. So this will become 2 squared plus 2. So that equals a 6. So now what that means is that wherever there is the g function, or in place of the g function, I'm going to substitute a 6 into the x of the f function. So now what I'm trying to find is f of 6, because g of x equaled 6. So now I substitute that 6 back into there. So that's going to be 3 times 6, which is 18. The other way to have done this is to have substituted in that x squared plus x into my equation here. So it would have been 3x squared plus 3x, then substituted in the 2, and you would have got the answer. So basically I could have done this first and then substituted in my value. This goes a little bit quicker. If I had done it this way, where I found the equation first and then did the substitution, I would have had 2 squared is 4, 4 times 3 is 12, plus 3 times 2 is 6, 6 plus 12 is 18. So I would have had the same answer. Doing it this way, substituting the value in first, saves you a little bit of time. Either way will get you the same answer. Okay, next example. The function composition f dot g of 2x plus 1. So what we're finding here, this is still going to be f of g of x. So what we're doing is wherever there is an x, we're going to substitute in 2x plus 1. So the first place we have to start, because this is the inner bracket, is to substitute in 2x plus 1 into the g function first. So that means I'm still going to find the function of f, but I have to solve my g first. Excuse me. So my g was x squared plus x, so that means I'm going to have 2x squared plus 1, all squared, that's my x squared, plus 2x plus 1. So this is the function of 2x squared plus 1. That leaves us with the function of 2x squared plus 1 plus 2x. So the f of x was equal to 3x. So that means that this function of this is going to be 3 times 2x plus 1 all squared plus 2x plus 1. So now this here replaces my x in my function of x equation. My function of x was equal to 3x, so 3 times that. That's where that came from. So now to do some solving, I'm just going to move over here a little bit. 3 times 2x squared plus 1 all squared using my shortcut. 2x is 4x all squared. 2x times 1 times 2 is plus 4x. Square my last term is plus 1, and then plus 2x plus 1. So I have 3 times 4x squared plus 4x plus 2x is 6x plus 2. So this works out to 12x squared plus 18x plus 6. So the biggest thing when you're doing these questions is to remember to first start with your innermost, do your substitution, and then substitute that into your last function. Okay, so the next one says, consider the functions fx is equal to square root x minus 3 and gx is equal to x squared plus 2. So the first one says to find the f dot g of x, which is also read the g of f of x. So this, if I write it out, is the same as saying the f of gx. It's a function of gx. So to start with, what I'm going to do is I'm going to substitute in x squared plus 2 wherever there is a x in my f function. I'm going to put this underneath here because I'm going to run out of room. So this equals, there's an x right here, so that means instead of that x, I'm going to have square root of x squared plus 2 minus 3. So x squared plus 2 minus 3 is x squared minus 1. The f dot g of 2, so this means that what I'm going to start with is f of g of bx, but this time I'm substituting in a 2. So this is going to be the function of 2 squared plus 2, which is just the function of 6. So now that means in my f function, wherever there was an x, I'm going to substitute in a 6. So this is going to equal square root of 6 minus 3. So square root 3 is my answer. Okay, so now we're going to go the other way. Instead of finding in this one we did g of f of x, in the first one here, in this one here we're going to do the f of g of x. So we're going to do the opposite composition that we did. So let's see what happens to our answer. So this one is saying substitute in an f of x wherever there is an x in the g value. So what I'm doing is I'm going to put this below it. So I'm doing g of f of x, so that means I'm doing the g of f of x is equal to square root of x minus 3. So that means wherever there was an x in my g function, I'm going to put in square root x minus 3. So this is square root x minus 3 all squared plus 2. So my squared and square root will cancel each other, so this is just x minus 3 plus 2, so this is equal to x minus 1. So the g of for the f of g of 4, this equals the g of f4. So wherever there is a 4 in my, an x in my f function, I'm going to substitute in a 4. So this is going to be, I'll do this going below, g of square root of 4 minus 1. So square root of 4 minus 1 is just 4 minus 1. Sorry, that should be a, no, that's right, 4 minus 3. There, that's my mistake. Let's put my answer in. 4 minus 3 is 1, square root of 1 is 1. So I'm actually going to be calculating the g of 1. So if I substitute a 1 into there, I have 1 squared plus 2, so that equals 3. I'm not doing the domain and range. We did a few of those already with the other one. You can take a look at a graph and pick out what the composite function will be. And it's similar to what we did in that first section of picking out the functions, but now you need to do 2 steps to it. So this, if you remember, g dot comp f of negative 4 means you're going to find the function of negative 4 and then substitute that into the g. So function of negative 4, so at negative 4, if my input is negative 4, what is my output? So negative 4 is over here. So f of negative 4 is equal to 0. So that means I'm going to find the g of 0. Oh, sorry, I guess you need to know which graph is which. This is the f graph. This is the g graph. So g of 0. So on my g graph, when my x is 0, x is 0, what is my y value? So this is at 3, or negative 3. So the f dot g of 3 means I'm going to find the f of g of 3. So g of 3, when my g, the x value was at 3, which is right here, my y value is 0. So what I'm going to find then for the composite function is the f of 0. So when my f function is at 0, that's right here. When, sorry, x is 0. What is my y? Well, it's up here. Not quite, like maybe 2.25. It's an approximate. It'll work. So the f dot f of negative 2. So this is finding the function of negative 2. So when my input is negative 2 on, or my x is negative 2 on this graph, what is my y equal to? So negative 2 is here. My y value is up here at 3. So what I'm finding then for the composition is the f of 3. When my x is a 3, so 1, 2, 3, what is my y on the f graph? It's up here at 1. So the g of 3. So I'm finding the g of 3. So on my graph, when my x value on my g graph, when x is equal to 3, my y is right there, so that means it is 0. So this is finding the g of 0. On the g, when x is 0, my y is down here at negative 3. In the last example here, I'm looking for the g of the f of negative 5. So f of negative 5. Negative 5 is right here. And my y then is right here, so that's at negative 2. So I'm finding the g of negative 2. So on my g graph at negative 2, which is here, my y is down about here, which is about negative 2.5. Okay, so the trick to doing from the graph is same thing as you did before. Work on the inside function, find the y value, substitute that as then the x value that you're going to find for your second function, and then you can find the y. So your questions are there at the bottom of the page. Good luck.